Parasitic drains suck. Customer complaints like, my battery goes flat after a couple of days can be a bit troublesome. So there's a couple of quick steps to make finding parasitic drains a little less painful. As always, the first thing that you want to do is confirm the fault. So you need a fully charged and load-tested battery, and the vehicle needs to be asleep, as in, all the modules and ECUs need to be asleep. So, on older vehicles, this can take between 35 and 45 minutes, and on newer vehicles, anywhere up to about 2 hours. So what you want to do is see how much current draw there is. So the total amount of current draw on a vehicle that's asleep can vary across manufacturer and years. So on an older vehicle, I would expect anything up to about 100 milliamps to be acceptable. And on a current model vehicle, I would expect anything up to about 200 milliamps to be acceptable. And always, obviously, we want to check the easy basics first. So make sure that there's no interior lights staying on, like the boot light or a glove box light. And make sure that there's no hot all times accessories fitted, like radios or CB radios or trailer brakes, something that's staying energized because it's hardwired to the battery when the key is off. So how do you measure current draw? Well, there's two methods. First of all, you could use a current clamp on the negative battery terminal, or a digital multimeter on measuring milliamps in series with the negative battery cable. Then, quite simply, measure the current flow, see if it's above or below the limits that are suitable for that vehicle. So how do you identify which circuit has the current draw? Well, there's two really easy ways. The first is with your current clamp or your digital meter installed in series, go to the fuse panel and remove fuses, taking note when each fuse is removed, if the current drops, and number two, how much current drop there is. You're obviously going to be looking for the circuit when disabled that causes the greatest drop in current flow. Okay, so the second method is to use a digital multimeter reading voltage, millivolts if it's non-auto ranging, and measure the voltage drop across the element of the fuse. So a circuit that has current flow will have voltage drop across the fuse. You can't have voltage drop without current flow. So you're only going to see two readings when performing this test. And that's either going to be 0.000 volts, meaning that there's no current flow, there's no difference in voltage between each side, there's no voltage drop across the fuse, or you're going to see a voltage drop in millivolts. So once you've identified which circuits have voltage drop across the fuse, then you can measure the current flow in that circuit by removing the fuse, installing your meter, and reading current flow in that circuit. Okay, so we've identified the total amount of current flow in the system. We've identified which circuits are energized and how much current flow there is in each of those circuits. And all you're looking for is any irregularity. So, obviously you're going to see a small amount of current flow on the radio fuse and maybe an ECU, but use your brain. If you see it on, the Parker lights, you know that there's obviously a fault in that system, as there shouldn't be any current draw there when the vehicle's asleep. So, taking you to step 3, which is fix it. So that's not watching me, that's out there on the car. So for more information, go to our website, www.olct.co.